In this video, we're going to apply the substitution method to solve a word problem. A small town has a population of 27,000 people. The population P of t will grow at the instantaneous rate of P prime of t is equal to 36,000 t divided by t squared plus 2 all squared, for t larger or equal to 0. T is in years, and t equals 0 represents the present. When will the population of this town reach 27,000 people? We're going to apply the fundamental theorem of calculus to solve this question. So f of b, capital F of b, is equal to f of a plus integrate the rate of change, integrate a to b, f prime of x dx. All right, so let's write that down. Population at time t is equal to population at time 0 plus integral from 0 to t, and we integrate the rate of change of population. That's dp dt, that's this quantity here. We're going to integrate that to get a total change in population. 36,000 t divided by t squared plus 2 all squared dt. So what that's telling us is the population at time t is equal to the population at time 0 plus we integrate the rate of change of population to get a total change of population from time 0 to up to time t. P of t is 27,000. Initial population of this town is 19,000. Plus integrating the rate of change from 0 to t, 36,000 t divided by t squared plus 2 all squared dt. Let's subtract 19,000 from both sides, and we get 27,000 minus 19,000, that is 8,000. And 36,000 is a constant, passes through the integral, so we get 36,000. Integral from 0 to t divided by t squared plus 2 all squared dt. So let's simplify this. Divide by 36,000. Divide by 36,000. So we get 8 over 36 is equal to integral from 0 to t divided by t squared plus 2 all squared dt. We're going to apply the substitution rule to solve this question. So we let u be equal to t squared plus 2. du is derivative is 2t dt. Divide by 2 both sides, we get 1/2 du is equal to t dt. Let's rewrite this integral to make the substitution rule easier to see. 1 over t squared plus 2 all squared times t dt. So we can see that this part of the integrand is going to be 1 over u squared. And t dt, this part, is 1/2 du. But we still need to change the limits. So t equals 0, which is the lower t limit, gets plugged into u. U is equal to t squared plus 2. And we get u is equal to 2. T is equal to capital T, gets plugged into u. U is t squared plus 2. And we're going to get u is equal to t squared plus 2. So we have integral from lower u limit is 2, upper u limit is t squared plus 2, and we have 1 over u squared times 1/2 du. 1/2 is a constant, passes through the integral, so we get 1/2 integral from 2 to t squared plus 2, 1 over u squared du. So what we have is 1/2 integral from 2 to t squared plus 2, 1 over u squared du. Now antiderivative of 1 over u squared is just negative 1 over u. So we get 1/2 integral of u to the minus 2 du, and the lower limit is 2, the upper limit is t squared plus 2. And when we integrate u to the minus 2, we reverse the power rule, so we're going to get 1/2 u to the minus 2 plus 1 is u to the minus 1 divided by minus 1 from 2 to t squared plus 2. So we get negative 1/2, simplifying, times 1 over u, evaluated from 2 up to t squared plus 2. We're applying the fundamental theorem of calculus. So let's put the upper limit in, and we get 1 over t squared plus 2, and subtract the lower limit, 1 over 2. Now, let's also put the left-hand side, which is 8 over 36, that's what we had initially, is equal to integral from 0 to t over t squared plus 2, all squared dt. Now, we solved this part, and the result is here, right there. So let's rewrite this as 8 over 36 is equal to negative 1/2 times 1 over t squared plus 2 minus 1/2. Let's multiply both sides by 2. So multiply this side by 2 and multiply this side by 2. The 2 cancels here, and we're going to get 16 over 36 is equal to minus 1 over t squared plus 2 minus 1/2. So we have 16 over 36 is equal to minus 1 over t squared plus 2 minus 1/2. Now 16 divided by 2, that's 8. 36 divided by 2, that's 18. 8 divided by 2, that's another 4 over 9. So simplifying this, we get 4 over 9 is equal to minus 1 over t squared plus 2, distributing the minus sign. And minus times minus is plus, we get plus 1/2. So we have 4 over 9 minus 1 over 2 is equal to negative 1 divided by t squared plus 2. And taking common denominator, 18. 18 goes into 9 2 times. 2 times 4 is 8. 18 goes into 9 times. 8 minus 9. That's equal to negative 1 over t squared plus 2. Let's bring the calculations up here. 8 minus 9 is negative 1 over 18 is negative 1 over t squared plus 2. We can divide both sides by negative 1, get rid of the negative signs. We get 1 over 18 is equal to 1 over t squared plus 2. Now let's cross multiply, and we get t squared plus 2 is equal to 18. Subtracting 2 from both sides, and we're going to get t squared is equal to 18 minus 2 is 16. Square root that, and we get t is equal to plus or minus 4. But since we're looking for number of years, we will only take positive time. T is equal to 4 years. So what we have shown is that it will take 4 years. So 4 years from now, 4 years from now, the population of this town, the population of town will reach 27,000. 27,000 people. So it takes 4 years for the population to reach 27,000. All right, thanks.